All right, let's get to any questions on homework.
Could you please do 38?
38. Were we supposed to do 38?
Uh,
I think we were supposed to just do the odds 35, 37, 39.
oh, okay, sorry.
No, that's all right. But if you stick around in the end, I can do 38 to show it to you. I just don't have it in front of me here. But
Okay.
at the end, I can do it for you.
Okay, thank you.
No problem. All right, no other questions? All right, so we actually got a ton of notes today, so let's go ahead and get started on those. At the very beginning here, we're just filling in all the relationships of f prime and f double prime, and they kind of go backwards and forwards, right? Every graph tells you something about the other graph. Okay, there are things on f that will tell us about f double prime and f prime and so on. Okay, so just going through this really quick, when f prime is positive, okay, so that's my derivative is positive, my original function is increasing. And when f prime is negative, my original function is decreasing. Kind of makes sense, right? If f prime is positive, it means my slopes are positive. Positive slope means we're increasing. Negative slope means we're decreasing. Okay. Relative max is found wherever f prime is 0 or undefined, and f prime changes from positive to negative, or f changes from increasing to decreasing. We have a relative max. Okay, just kind of makes sense that we're going from increasing to decreasing. We would have a max. Okay, and then the other one, relative min, is when f prime is 0 or undefined, and f prime changes from negative to positive, meaning decreasing to increasing. Okay, that's all written up there. So decreasing to increasing obviously means we have a min. Okay, then we get to f double prime. When f double prime is positive, f prime is increasing. That's not something we've talked about a lot, but everything that f prime tells you about f double prime tells you about f prime. Okay, it's the same relationship. Okay, so when f double prime is positive, f prime is increasing, and f is concave up. And then when f double prime is negative, f prime is decreasing, therefore f is concave down. Okay, wherever we have critical numbers on f double prime, meaning where we're 0 or undefined, and we change signs, we'll have a point of inflection, which means we're changing our concavity from either concave up to concave down or vice versa. And typically our critical numbers that we're looking for when f prime is 0 or undefined. Okay, we're going to go through this pretty big packet here today. We're not actually going to do it all. Some of the ones in the notes are actually in the homework, so I'm going to get to skip them. But these are just talking about all the relationships that you're going to have, and then some of them are very typical of what a FRQ might look like when we get to the backside to some of these. All right, so obviously the first thing you need to do is, and you've been working all your life on these skills, is I got to identify what I need to find. Okay, I need to find relative mins and relative maxes on f of x. Okay, whatever the graph of f of x it looks like, I don't know. Whatever the function of f of x is, I don't know. I'm given f prime. Okay, but I need to make the relationship that says mins and maxes are where f prime is 0 or undefined. Okay, well, this is a polynomial, so it's only going to be 0. So I find my critical numbers by setting each one of these factors equal to 0. Okay, hopefully we can just look at it visually and see that at -2, at +3, and at +1, I'm going to be 0. Okay, so I've identified critical numbers. Now I'm going to make a sign table. Okay, I got x, I got f prime, and I got f. And I have my 3 critical numbers and then the intervals, right? So my first critical number would be -2. My next one would be 1. And my next one would be 3. And then this is less than -2. This is in between -2 and 1. This is in between 1 and 3. And then this is greater than 3. Okay, and we're going to figure out what f prime is doing, and that will help us with f. Okay, so I pick a number less than -2, and I'm going to plug it in here. Okay, so if I pick -3, that'll be negative. That'll always be positive, and that's going to be negative. Okay, so a negative times a negative times a positive is going to leave me with a positive here. Okay, we know at -2 we're 0. A number between -2 and 1, we pick 0, we plug it in. When we plug 0 in, we're going to get a positive here. Again, always positive here because we're squaring it. And then here we're going to get a negative cubed, and a negative cubed is a negative. So a positive times a negative will give me a negative. Okay, we know at 1 we're 0. We're going to pick a number between 1 and 3. We'll pick 2. 2 plus 2 will be positive. Again, that's positive. And 2 minus 1 is positive. Cubed is positive. So a positive times a positive times a positive will give me a positive. And then picking a number bigger than 3, I'm going to get positive, positive, positive. So I'm positive here. Okay, when f prime is positive, f is increasing. When it's negative, I'm decreasing. Increasing, increasing. So here I'm going from positive to negative or increase to decrease, which means I'm going to have a max. Here I'm going from decrease or negative to positive or decrease to increase, which is going to be a min. And here I'm not having a sign change, so neither. Okay, you could just put an n. The only reason we can't put an m here and m here is because min and max, but for n, you could just put n. All right, so the question now, we have to go back and says, find all the relative min and relative max. Now, what it didn't say that it needed to say was, we need to justify. Okay, the sign table is not enough to justify. We have to use our definitions up here. Okay, so we'll just start with relative max. So I'm going to say we have a relative max at x equals -2. And then we're going to justify because, okay, what makes a relative max? F prime has got to be equal to 0, which it is. So f prime of -2 equals 0. And it has to change from positive to negative. Okay, and so we'll say that. And f prime changes from positive, I'm just going to say POS, to negative NEG. Okay, you can use abbreviations like because and shorten things up, but abbreviations that you use have to be common abbreviations. You can't just make up your own abbreviation and expect someone in Kansas City that has never met you before to understand your abbreviations. Maybe I understand them because I know you better than they do, but you do have to use common abbreviations. All right, the next one we'll say is a relative min at x equals 1. And basically the same thing because we know f prime of 1 is 0. And f prime changes from negative to positive. Okay, so we're getting more into now how answers are going to be written, especially when you get to FRQs and you have to justify any type of answer. Okay, but a very common typical FRQ question right there is given f prime, finding mins and maxes on f. All right, there are a few other things that are going to help us along the way as we're graphing, and we're doing all of this without a calculator, and the quiz on Friday is non-calculator, okay? But finding x and y intercepts, okay? We'll start with x intercepts. To find an x-intercept, when you have a rational function, you're going to set the simplified numerator equal to 0. Nothing is going to cancel when I factor the numerator and the denominator, so I don't have to worry about there being a hole anywhere if you remember all that stuff. But so to find the x-intercept, I'm going to set x squared minus 9 equal to 0 and solve this equation and get x equals plus or minus 3 I'll write that as an ordered pair, plus or minus 3 comma 0 are my x-intercepts. This is just really like a refresher course for you. All right, to find the y-intercepts, we're going to plug 0 in for x and get 0 squared minus 9 over 0 squared minus 4, which is going to give me 9/4. Okay, so x is 0, y is 9/4. All right, another refresher on horizontal and vertical asymptotes. The rules for horizontal asymptotes are when the degrees are the same, it's the leading coefficient. So the horizontal asymptote is going to be at y equals 1/1. And vertical asymptotes are any numbers that make your denominator 0 that didn't cancel due to a hole. Okay, if you remember, if it cancels with something in the numerator, it's a hole. If not, it's a vertical asymptote. So we're going to set x squared minus 4 equal to 0 and get x equals plus or minus 2. So we actually have 2 vertical asymptotes there, 1 horizontal asymptote. Okay, that's just a refresher for what we're getting into next. How to find mins and maxes, x and y intercepts, horizontal and vertical asymptotes are going to help us with what we're doing on the next page, which is the whole thing from beginning to end of a problem. Do I have any questions so far? All right. So number 4 is giving you f of x. We don't have a calculator. It's obviously a cubic function. We can tell just by looking at that. It's a cubic polynomial. Okay. You're given the factored form and you're given the expanded form just to kind of save on time for you as far as some things go. Okay. So determine the x and y intercepts. It does not matter which one you're going to use. Let's start with y intercepts. I'll plug 0 in for x. And when I do that, I'm going to end up with 4. So my y-intercept is going to be 0, 4. And to find the x-intercepts, I set my factored forms equal to 0. Okay, so I set these equal to 0, and I get x equals 2 and x equals -1. So 2, 0, and -1, 0. Okay, in the end of this entire problem, we're going to not only analyze the graph, but we're going to sketch it without a calculator and get pretty accurate on this sketch. So I'm going to go ahead and jump down and plot those 3 points. I have the point 0, 4, which is a y-intercept. And then I have -1, 0, and 2, 0 as my x-intercepts. And then we'll get back to the graph as we go. All right, question B says determine the first derivative and find the critical numbers, okay? So the first derivative, we're going to do that out of expanded form. There's no point in doing like some sort of product rule here. Product and that would be a chain rule. Okay, so much easier when you have a polynomial in expanded forms. The derivative of x cubed is 3x squared. The derivative of -3x squared is -6x. And the derivative of 4 is 0. To find our critical numbers, we set our derivative equal to 0 and solve. Okay, so I'm going to factor out a 3x, and I'm left with x minus 2 equal to 0. So I get critical numbers of 0 and 2. Okay, part C says complete a sign chart for f prime of x to determine the intervals where we are increasing, decreasing. And obviously in our sign chart, we're also going to go ahead and find where we have relative mins and maxes and identify those points. Okay, so we have critical numbers at 0 and 2. So we have x, f prime, and f. 0 and 2. Less than 0, so -infinity to 0, between 0 and 2, and greater than 2. Okay. You can be kind of casual with your sign chart as far as the AP exam goes. I want you to make sure you're filling it all out for me. So you would put -infinity to 0, 0 to 2, and 2 to infinity up in here. We know these are zeros. I'm gonna kind of do this quickly. You could go back and ask me about the algebra later, but if I pick a number less than 0, I'm gonna get a positive value here. If I pick a number between 0 and 2, I'm going to get a negative value. Remember, I'm plugging this into f prime. And if I pick a number greater than 2, I'm going to get a positive number again. So I'm increasing, I'm decreasing, I'm increasing. While I'm here, I'm going to go ahead and identify if I'm changing from positive to negative, I have a max. And if I'm changing from negative to positive, I have a min. Okay, this specific question is asking intervals where we're increasing and decreasing. So we'll go ahead and start with increasing. We're increasing from negative infinity to 0, union with 2 to infinity. And we need to justify that, okay? And the way we're going to justify that is we'll just say because f double prime is positive. F prime, not double prime. F prime is positive. Whenever f prime is positive, f is increasing. And then my decreasing interval is going to be 0 to 2. And the reason is because f prime is less than 0. Okay, that's your justification, not the sign table. We just need the sign table as a tool to get to our justification. All right, is everybody good, or does anybody need more time? Okay, relative mins and maxes, and it says give the coordinates. So we'll start with relative min. Our relative min is when x is 2, and then we got to go back into the original function, okay, whether it's the factored one or the expanded one. It does not matter where you're going to plug that 2 in and get our y value. Well, right here, if you do 2 minus 2, you're going to get 0 times this. So it's going to be a 2, 0. Okay, and we justify that by saying because f prime of 2 equals 0 and changes from negative to positive. That's our justification for a min and a max, just like we did back there on question 1. Okay, then a relative max is going to be at 0. Again, go back to the original, plug 0 in, and you get 4. And we say because f prime of 0 equals 0 and changes from positive to negative. Okay, those are points that are going to be on my graph of f of x. So I'm going to go ahead and go down to my graph and plot those really quick, okay? 2, 0, and 0, 4 are already plotted, okay? Because 2, 0 was my x-intercept and 0, 4 was my y-intercept. So kind of lucked out on in that case that they're not different points. So I'll make the graph a little easier. All right, E says determine the second derivative. Remember, we're going from the first derivative, which is right up here in B. Okay, so my second derivative, f double prime, is going to be 6x minus 6. Okay, it didn't say it here, but obviously we're going to need to find our critical numbers on our second derivative. So set 6x minus 6 equal to 0. And we're going to get a critical number of 1. Okay, and what's possible at that critical number would be a point of inflection. Okay, now we're going to go down here in F and make our sign chart again, but this time we're only concerned with what F double prime is doing. Okay, my only critical number is 1. So this is negative infinity to 1, and this is 1 to infinity. We know at 1 we're getting 0. And we are plugging into our second derivative, which is this function right here. When I plug, let's just pick 0 in. 6 times 0 minus 6 is negative. When I pick a number bigger than 1, 6 times 2 minus 6 is positive. Remember, we're not increasing, decreasing. We're concave up or concave down. That's our second derivative. Here we are concave down. Here we are concave up. So here we have a point of inflection because we changed signs on the second derivative. And then we will go ahead and identify the point where we have a point of inflection, the actual point. Okay, it's at x is 1. And when I go back to my original, again, remember, don't plug it into your derivative. You're just going to get 0. Okay, we already know it's a 0 in the derivative. When I go back to the original, I plug in 1, I get a y value of 2. Okay, so my point of inflection is at 1, 2, and I'm going to justify that. Okay, to justify points of inflection, a point of inflection is where f double prime is equal to 0 or undefined. So f double prime of 1 is equal to 0. And what has to happen? We don't have to change from positive to negative or negative to positive. We just have to do one of them. Okay, unlike mins and maxes, it's very specific. As long as we are changing signs, we have a point of inflection. Okay, it doesn't matter about positive or negative, positive to negative or negative to positive. Okay, so before this problem ever started, we should have had an idea of what an x cubed function looks like. We know that it looks something like that. Okay, it's a positive x cubed function. We know it's going to have 2 changes, 2 humps. Okay, it's going to start down here in the bottom left. It's going to finish up here in the top right. But now we have the ability to make it a little more specific. Okay, because we know that we are increasing from negative infinity to 0. So we're down here and we're increasing from negative infinity to 0. Okay, here's my x is 0. And when I get to the point 0, 4, that's a relative max. Okay, so if you remember back in pre-calc or even in algebra 2, we used to tell you it doesn't matter where you put your mins and maxes, you just kind of turn it. Now we have the ability to find where those turn. Okay, so now we're turning. We're decreasing from 0 to 2, just like it says right here. I'm now decreasing, and I'm going to have a relative min here, and then I'm going to turn again, and I'm going to be increasing from 2 to infinity. Okay, and that's exactly what our graph says. Now, what are these exact points in here? We didn't find those, but those can easily be found by creating a table. All right, do I have any questions?
On G, if we were to write, it changes from negative to positive where we get it wrong.
No, you wouldn't get it wrong. You're just, I hate to say you're wasting time. You're not really, you're not really wasting time, but you do not have to say that. Okay. All you have to do is basically your justifications are going to be these things right here. Okay. And so if you can say change the signs, if you say specifically the sign change, it does not, it's not wrong. It's just not necessary. Okay.
Okay. Thank you.
You're welcome. All right, I'm going to go ahead and skip 5. It's very similar to what we just did, except it's a rational function, okay? But you're doing the same things. If we have time in the end, I'll get back to that. So let's go over to number 6. Okay, number 6 is you're given a ton of information and asked to sketch the graph. We have no idea what this graph is going to look like going in, but we're just going to take each piece of information and dissect what it means to us, okay? So the first thing is f of negative 2 equals 8. That's just a point. Okay, go plot the point negative 2, 8. Okay, as well as the next 2 pieces of information. They're both just points on a graph. Okay, so I'm going to plot the point 0, 4, and I'm going to plot the point 2, 0. All right, the next piece of information tells me f prime of negative 2 is 0 and f prime of 2 is 0. Okay, those are not points on my graph. This is the graph of f. Okay, I'm going to write that here. This is the graph of f of x. This is telling me something on f prime. But here's what it does tell me, which is important. It tells me, remember, whenever the derivative is 0, it's a critical number. Okay? And critical numbers are where we have mins and maxes. Okay? We'll get to that in a minute of which one it is. I think it's pretty obvious looking at this graph. -2 is going to be a max and +2 is going to be a min. But you never know. This could be a relative max. We could be up here. And who knows, this could be coming from down here, right? Okay, but it appears that way. All right, now look right here. It says f prime is greater than 0 when x is less than -2, and it's greater than 0 when x is greater than 2. What this is telling me is I'm increasing, right? When f prime is positive, f is increasing. Okay, we're not there yet. We're just dissecting the information. When f prime is negative, between -2 and 2, f is decreasing. So I'm decreasing from -2 to +2. F double prime talks about concavity. When f double prime is positive, I'm concave up. Okay? And when f double prime is negative, I am concave down. Okay, now if you actually break down this information in here, okay, f prime is positive when x is less than -2. Okay, so to the left of this, f prime is positive, which means f is increasing. Okay, so I am increasing from down here all the way till I get to here, and then I'm going to start decreasing. Okay, that tells me I have a max here. Okay, when f prime is -2, I'm equal to 0. Okay, and then I'm going to go from increasing to decreasing. So it's a max. And then I'm decreasing from -2 to 2. And then I'm going to change to increasing. And I was able to sketch this graph here without ever knowing anything but 3 points on that graph. Okay, based on knowing the information that I can dissect from derivatives, first derivative and second derivative. Okay, like I said, those relationships on that front page are extremely important. Okay. All right, number 7 gives us a table. So notice that, this will happen all year. Okay, there are 3 ways you're going to be presented the problems in calculus. Okay, algebraically, which is number 4, we're given a function. Okay, and then I guess this could be considered algebraically. This is definitely numerically. Okay, and then graphically would be the other one. We're kind of doing the reverse of graphically here, but these are the ways that information will be presented to you. This time we got a table. Okay, in our table we have certain intervals and values of x, and then we have values at f prime and f double prime, whether they're positive and negative or 0 or undefined. Could be undefined. Okay, so 7a says, what is the x coordinate of the point of inflection? Okay, we got to think back. Points of inflection are where f double prime is 0. So I got to go find f double prime and find f double prime when it's 0. It's right here. Okay, the x coordinate is 4. So x equals 4. We must justify. Well, I just stated the justification, right? Okay, oh, and by the way, one thing I forgot to state is we're changing signs on the left side of 4 and on the right side of 4. So it is a point of inflection. So f double prime, I'm just going to say f double prime equals 0. And f double prime changes signs. All right, 7b, is f of 9 a min, a max, or neither? Justify. Okay, mins and maxes come from f prime. So I'm going to go find 9. First, f prime of 9 must be 0. It is. And we must change signs. We do. We, on the left side, we're positive, and on the right side, we're negative. So we're changing from positive to negative, or increasing to decreasing. So we're going to have a relative max there. So we're going to say we have a relative max. And to justify, right, relative max, min, or neither, that's a 33% shot of guessing the right answer, okay? The justification is the important piece here, okay? As far as when they're going to grade this on the AP exam for you, okay? So stating relative max is a portion of it, but this is the bigger portion. Because f prime of 9 equals 0, and f prime changes from positive to negative. All right, 7C is asking us something about f prime, okay? We haven't really done something like this yet, okay? But it's asking us something about f prime. It's asking where is f prime increasing, okay? The graph of f is not going to tell us that. The graph of f double prime is going to tell us that, okay? F is increasing where f prime is positive. So f prime is increasing where f double prime is positive. Okay. I've just justified my answer. Now I just need to go find that. Okay. F double prime is positive all the way from x is less than -5. Okay. So that's negative infinity all the way through to 4. So from negative infinity to 4, f double prime is positive. Okay, obviously when we get to 4, we're 0. Okay, so from negative infinity to 4, we are positive, where f prime is increasing when f double prime is positive. Questions? All right, number 8 is an extremely common question on the AP exam. Okay, B is going to be in your homework, so that's why I cross it out, and all of 9 is in your homework. So I cross that out here. But you're given a graph over here. So to the right is the graph of some function g. So we'll just say g of x. Okay, it's not a derivative, it's not a second derivative. It's an original function, which has a relative min at x equals 1. Okay, which means we have a horizontal tangent here. There's a min. And we have a relative max at x equals -3. Horizontal tangent there. Rank these values in order. Okay, so here's what you need to know before we get into this problem. Okay, when they give you 3 values like this, we're not going to be able to find specific values. G prime is a slope. Okay, G double prime is a slope, or it's talking about a concavity. Okay, we're not going to get specific values out of this. What we're looking for is one of these numbers is going to be 0. One of these numbers is going to be positive, and one's going to be negative. We can then rank the 3 in order. Okay, G of -3 is a point. G of -3 is positive something. That doesn't matter what it is. It's positive. So I'm just going to put a positive up here. G of -3 is the slope of G at -3. Well, it told us that we have a max there, which means the slope there is 0. And G double prime of -3 means what's the concavity at -3? Okay, and the concavity at -3 here is we're going to be concave down, right? We are concave down if this graph continued to some point of inflection over here, but we're concave down because all my tangent lines are above, right? When my tangent lines are above, just like this one right here, we're concave down. So this is negative. So now I can rank them in order. G double prime is my smallest number. G prime is my second because it's 0, and G is my largest number. Okay, very common question on the AP exam, not given a function, so you can't actually plug numbers into something. You're just given a graph, and you just have to understand relationships, okay? This whole lesson is about those relationships on the front page.
Can you explain G prime one more time, please?
Yeah, G prime is the slope, right? G prime means slope at -3. And since they told us we have a maximum at -3, that means the slope of the tangent line, its slope of the tangent line is 0. It has to be a horizontal tangent there because it's a max. Okay. Therefore, slope is 0.
Okay, thank you.
You're welcome. All right, go ahead. We're on the last page here. Number 10 is going to be in your homework. This time you're given 3 graphs, and you're going to have to figure out which one's F, which one's F prime, and which one's F double prime. Every graph tells you something about the other graph. Okay, so that's in your homework. We're going to go to these last couple here. All right, number 11 says f of x is continuous and twice differentiable. Okay, that obviously has important meaning to it. It's got to be differentiable, right? The graph of f of x has extreme values at x equals 2. Okay, if f double prime of 2 is equal to 9, does f of x have a relative min or a relative max at x equals 2? Okay, what does f double prime of, first of all, we know we have an extreme value, right? So we know that we either have a min or a max. Okay, and then it says you have a min or a max. And this is what we learned yesterday, if the second derivative is positive, that tells me my graph is what? Concave up or concave down?
Up.
That's correct. Okay, if I am concave up at 2, then I obviously have a relative min. Okay, so I'm going to say I have a relative min, and my justification is because f double prime of 2 is greater than 0. Okay, and that's the thing that we talked about yesterday in the box at the beginning of the notes was some theorem, whatever the theorem number was, is if f double prime, if f prime is 0, and we know f prime is 0 because it tells us it's an extreme value or critical number, okay, then, and if f double prime is positive, then we have a relative min, and if f double prime is negative, we have a relative max. All right, number 12 says f prime is this function. This is a derivative, not an original function. Is f of x concave up or concave down at 4? Show the work that leads to that. Well, what tells me if I'm concave up or concave down is my second derivative. Okay, so I'm going to find my second derivative and then plug in 4. The derivative of 5x is 5. And the derivative of 2e to the x is 2e to the x. I'm going to plug a 4 into that. And I'm going to tell you that this is most likely non-calculator. Okay? You just have to know this. E to the 4, well, e is 2.7 something. And 2.7 something raised to the 4th power is going to be bigger than 16, because I know 2 to the 4th is 16. Okay? So this is going to be bigger than 16, times 2 is going to be bigger than 16, and 5 minus a number bigger than 16 is going to be negative. Okay? I'm just going to say this. F prime of 4 is equal to 5 minus 2e to the 4th, and I'm just going to say is less than 0. Okay? That's how we justify right there. Okay? We don't have to actually find the actual value. I know they're not going to put this on a calculator section, because if you could do it on a calculator section, you would just graph it, and graphing it you would just be able to see. Okay, so we got to show the actual calculus that leads to it. We have to prove f double prime of 4 is either positive or negative. Since it's negative, our answer is we are concave. We're negative, so we're concave down. All right, last one is there's a little typo in here. The graph of f double prime is over here. Okay, that should have been an F in there. I think it auto-corrected because it said of f, and it didn't like that. But this is f double prime. It's on the open interval -7 to 7. Okay, so we don't know what's going on to the left. We don't know what's going on to the right. But here's what we know. F double prime of -2 equals f prime double prime of 4, which is 0. Okay, so at -2 we're 0, and at 4 we're 0. and f double prime has a horizontal tangent at x equals 1. The two questions are, well, they're different. The first question is, in what intervals is f concave up? Okay. Please remember, they're 99% of the time, they're not going to ask you a question about the graph you see. They're going to ask you a question about the graph you do not see or the equation you do not see. Okay. This is f double prime. They're asking us about f. Well, where is f concave up? The justification is when f double prime is positive. That's the graph of f double prime. I go find when I'm positive. That's why they had to tell me what these exact zeros are, so I know when I'm positive. I'm positive from -2 to 4. Not equal to, so no brackets there because I'm 0 there. Not positive, I'm 0. And the last one, where is f prime decreasing? Again, we haven't talked much about this, but you have to keep this in mind. Okay. Whatever f prime tells us about f, and that's 99% of the questions, right? Is f prime positive or negative? That tells us if f is increasing or decreasing. Okay. The relationship of f double prime to f prime is the same. Okay. F double prime tells you about f prime what f prime tells you about f. Okay. And going both directions, it works both ways. Okay. So f double prime doesn't necessarily have to be only talking about concavity. If it's talking about f prime, it's talking about where is f prime increasing, decreasing. Well, f prime is decreasing where f double prime is negative. Just like f is decreasing where f prime is negative. Okay, so now f double prime is negative on the intervals -7 to -2, union with 4 to, what is that, 7. Okay, your quiz is going to be very similar to this right here, and then your review tomorrow will be the same. Okay, so it's going to be just a lot of questions where it's just asking you increasing, decreasing, that kind of stuff. I'm not going to have you graph because I don't know if you're going to cheat and use a calculator. Okay, I do know that Josh Souza is in the building, and he's told me many stories about some of you out there. No names were mentioned, so don't get mad at Josh, and I don't care. But just remember your goal is to pass the AP exam at the end of the year, not to pass this class. Okay, but it is non-calculator on Friday for the quiz. So you're going to have to answer questions about this, and you're going to have to understand these relationships. Okay, those relationships at the very beginning, wherever they went there, are extremely important for this whole unit going all the way to the end of the semester. Okay, so get those down forwards and backwards, and you should be fine on this quiz. If I have any wait, let me just remind you, tomorrow, no Zoom meeting. Okay, we will be you're just working on the review. I will submit the attendance. You do not need to check in with me. I'm just going to mark everybody present, work on the review. I'm going to post the solutions to this assignment, and I will post the solutions to the review. And then Thursday, we'll go over both of those assignments. That will be all we do on Thursday, and then Friday will be the quiz. No Zoom again on Friday. And we'll go forward from there. Okay. If you have any questions, please stick around. If not, you guys have a great day.